All right, in this video, I'll be completing the last 5 slides of the notes for 9.1. Keep in mind, if you haven't seen the video for the 9.1 worksheet, that's where I did the 2 examples that are in the previous 4 slides before this one, which is slide 31. And so you may want to look at that first. So let me go ahead and wrap this up. So I'm going to go ahead and put in a number here. It says interpreting confidence intervals. We are 95% confident that the population proportion is between whatever we give as a lower bound and our upper bound. So this is another way to say that the method for estimating is correct 95% of the time. If 100 different confidence intervals are constructed, each based on, it should say, a different sample of size n, from the same population, we would expect, and I don't need a percent here, we would expect 95 of them to include the population parameter, which in our case is p. So 95 times p would be in our confidence interval, and 5 times it wouldn't if we had 100 different confidence intervals from 100 samples. I want to make a comment here. What we don't say, it's not the language that we use, and that is a 95% confidence interval does not mean that there's a 95% probability that the interval contains the parameter. So we don't consider it a probability, it's just a confidence level. And last comment on that, a 95% confidence interval means that 95% of the samples are expected to contain the population parameter, in this case p. Let's continue on that in the next slide. If the 95% confidence interval you find is this interval here, so from 460 thousandths to 522 thousandths, so we're saying that p is somewhere in here, at least in section 9.1. Is it possible that the population proportion could be 0.60? Yeah, it is possible, but not likely because 0.60 falls outside of the interval. A population proportion of 0.60 would occur in only 2.5% of the samples. Well, remember, 95% of our intervals, of this interval here, should capture p, and 5% of the time it'll be outside of that, half of it here and half of it there. That's why it's 2.5%. Basically, 0.60 is in the upper tail of the distribution. All right, let's move on to the next slide. So finding confidence intervals in StatCrunch. Now I actually used this in problem number 3 in that video on the 9.1 worksheet. So I would encourage you to look at that. And but anyway, this is the place you go to use StatCrunch to find a confidence interval, and you can see how to do it in that example. I want to show you another type of problem and how we'll use StatCrunch to solve it. You'll be asked to find the sample size needed when given a confidence level and a margin of error. So for example, a researcher wishes to estimate the proportion of adults who have high-speed internet. What size samples should be obtained if she wishes the estimate to be within 0.04 with a 90% confidence if she uses a previous estimate of 0.36 for the population proportion, so that would be our p, or B, she does not use any prior estimates. So if we're within 0.04, that's basically 4%. This is our margin of error. And of course, our interval is going to be twice that. So you basically have your confidence interval with your lower bound and your upper bound. You have P in the middle, or P hat, and this is your margin of error. So if you double that, that gives you this interval length, which is what they're calling width in the, you'll see in the on the next slide that shows you what you're going to see in StatCrunch. So let's go ahead and do that and we'll come back. So we're going to go to Stat, Proportion Stats, Power, and in the middle here I think it says one sample. And then you have to choose Power/sample size. You're going to select confidence interval width. This is where you're going to have your confidence level. This is where you're going to have your p-value. Like in part A, we had a p-value. Notice it says if p0 or p-hat is not known, we'll use 0.5, which is kind of, it's in the middle. It's a guess. But we can use that to figure out sample size. And then our width goes here, which again is double the margin of error. So let's go ahead and do that, and we'll solve the problem we were looking at. So let's go ahead and do part A. So I'm going to switch to StatCrunch. So we're going to go to Stat and Proportion Stats, one sample. Now in the example that I did for problem number 3 on the worksheet for 9.1, we went to a summary. Here we're going to go to power sample size. Let me bring this over. We want to go to confidence interval width, and ours is a 90% confidence interval. Our target proportion, we said it was 0.36, and the width was 0.08. So when we hit enter, we get 390. So that's the answer to part A. And so now we're going to assume we don't have a given target proportion. So we're going to use 0.05. I'm sorry, 0.5. I'm just going to make sure this says 0.08. And when we hit enter, we get 423. So I'll just switch back real quick. We got 390 in this case and 423 here. All right, so that's it for the 9.1 notes. And if you have any questions, just let me know.